Hey, welcome back. This is a test 4 review. So the sections that we're covering will be 11.1 to 11.4 and then 12.1 to 12.5. Okay. All right, so I'll go through and kind of give you a heads up as to what kind of questions I'm looking for. So from the book, problems 35 to 61 and 11.1. And what we were doing here was solving quadratic equations by completing the square. Okay, so solve by completing the square. Okay, all right, so let's look at 41. We're given basically the quadratic equation in standard form. It's already set equal to 0. For these problems, you want to move the 2 to the right side, so you get x squared plus 2x equals negative 2. Then the magic number you want to add in is the b value. The b value is in front of x, so in this case it's 2. And then all over 2 squared, right? So 2 over 2 is 1, and of course 1 squared is just 1. So when I add 1 to both sides, that completes the square. So it gives you a perfect square trinomial. If you add it to the left, you have to add it to the right side, and then you could factor this. On the right side, we have a negative 1. Then do the square root property, so I'll have x plus 1 equals plus or minus square root of negative 1. So we will work with imaginary numbers in this section. We'll have x equals negative 1 plus or minus square root of negative 1, of course, is just I, so we'll write I. Okay. Let's look at another one, number 51. Here I have 3x squared plus 6x plus 1 is 0. So the issue, firstly, that you have to take care of is that leading coefficient of 3. So what you're going to do is divide everything by 3. So you'll end up with x squared plus 2x plus 1/3 equals 0. And then you proceed like in the previous problem. So you're going to move the 1/3 over. Then you're going to get your magic number. So in this case, it's the same. B over 2 squared. So b is 2. 2 over 2 is 1. 1 squared is 1. Okay, so I'll have x squared plus 2x, and I have to add in 1 to make it a perfect square trinomial. Add in 1 on the other side. 1 is the same as 3 over 3, so just getting a common denominator out of the way. Go ahead and factor on the left, so I get x plus 1 squared. On the right, you'll have 2/3. And then square root property says we have x plus 1 equals plus or minus square root of 2/3. I'm going to want to simplify that plus or minus. I want to, rationalize the denominator, right? So this is the same as plus or minus root 2 all over root 3. So I want to multiply top and bottom by root 3. And that's going to give me plus or minus root 6 all over root 9, which is just 3. So I'll end up with moving the 1 to the right, negative 1 plus or minus root 6 over 3. Okay. From there, we started working with the quadratic formula. So you have to have the quadratic formula memorized. This is section 11.2, looking at problems like 1 to 17. Okay. Again, you can have imaginary numbers in your answers, so just be aware of that. Anyways, number 6, x squared plus 5x minus 10 equals 0. Your a is what's ever in front of x squared. Your b is what's ever in front of x. And your c is the constant, negative 10. So we'll have x equals negative b, so negative 5, plus or minus the square root of b squared, which is 25, minus 4 times a times c, all over 2 times a, which is 2. Okay. This will be negative 5 plus or minus the square root of 25 plus 40, all over 2. That will be then negative 5 plus or minus the square root of 65, all over 2. And there's not anything else you really do, right? 65 doesn't have any factors that are perfect squares, so you're kind of stuck. Okay, and that will be as good as you can get it. Let's look at number 11. So I have 4x squared minus 3x equals negative 6. This guy isn't in our standard form. We need to have it set equal to 0. So the first thing I'm going to do is move that 6 to the left-hand side. So plus 6 is 0. Then you can identify your A, B, and C values and plug it into your quadratic. So x equals negative b, so negative 3 is 3, plus or minus the square root of b squared, negative 3 squared is 9, minus 4 times a times c, all over 2 times a. So I'll end up with 3 plus or minus the square root of 9 minus 96, all over 8. And it looks like we're going to have a negative for our discriminant, and that's okay. That just means our solutions will be imaginary. So negative 87 all over 8. I like to rewrite my imaginary numbers in back. So 3 plus or minus the square root of 87i. And as long as you put that hook there, that's fine. You just have to make sure people don't accidentally think you put the I in underneath the square root, because that wouldn't be correct. So anyways, when you have an imaginary number, you have to split these things up so it's in kind of our standard form, right? You want a plus bi. So you're going to have 3/8 plus or minus the square root of 87/8 I. Okay. The next section was on graphing quadratics, so graphing parabolas basically. There were two types of problems. The one when the quadratic is given in kind of the vertex form, like number 23, 2 times x plus 2 squared minus 1. This form's nice because you could read the vertex right off the equation. Anyways, first identify the a value, the leading term basically. In this case it's 2. That's positive. That means it's going to be a happy face. Okay, so you have to make a comment about the a value, and then if it's concave up or concave down, in other words happy face or sad face. Then get the vertex. And in these cases, you could just read the vertex off the formula. So negative, opposite sign, and then same sign, -2, -1. Thirdly, I'll probably ask for the domain and range. The domain is always going to be -infinity to infinity for parabolas. The range then is always based off of the y-coordinate of the vertex and the orientation of is it happy face or sad face. So if it's happy face, it's going to go from the y-coordinate -1 to infinity. Okay. Fourthly, then you need the x and y-intercepts just to graph the thing. So for the x-intercept, you let y equal 0. So you get 2 times x plus 2 squared minus 1. You can add the 1 to the other side. I'm going to flip-flop sides though. So I'll have a 1 over here. Divide by 2. Square root property says x plus 2 is plus or minus square root of 1/2. And again, I always like to rationalize my denominators. So plus or minus, it'll end up being square root of 2 over 2. Okay. Then I want to move the 2 to the right hand side, so carrying on, I get x equals -2 plus or minus radical 2 over 2. For graphing purposes, I want to get some approximations for that. You punch it into your calculators, you get -1.29 and then -2.71. Okay. Also need the y-intercept for graphing. So for the y-intercept, you let x equal 0. So we'll have y equals 2 times 0 plus 2 squared minus 1. Order of operations, do your parentheses first. So I have 2 times 0 plus 2 is 2, and then I got to square that. Please excuse, so now exponents, 2 times 4 minus 1. My dear Aunt Sally, so multiplication, 8 minus 1, and then subtraction, 7. Okay. All right, so now I'm going to compile all that information into a picture. And so 1, 2, 3, 4, 5, 6, 7. -1, 2, -1, -1, 2, -1, and then 1, 2, about 1, 2, 3, 4, 5, 6, 7 is the y-intercept, and then the x-intercepts at -1.29, and then -1, 2.71, And that'll do it. Okay, so just connect the dots. It should be, I butchered that, I'm sorry. It should hit the y-axis at 7. I just kind of butchered it, so hopefully, you know, within reason, make sure it looks nice. And yeah, okay. So there's those kinds. Then there's also the ones where you have kind of this sort of y equals ax squared plus bx plus c form. The book gives this guy in kind of the reverse order of what I would write it. I would probably rewrite it as soon as I got it as negative x squared minus 4x plus 5. And then I could, you know, identify the a value. So first a is -1, which is less than 0, so it's a sad face. Secondly, then the vertex. So for the vertex, you have to have the vertex formulas memorized. So the x-coordinate is going to be -b all over 2a. So in this case, -4 is 4 all over 2 times -1 will be -2. And then for the y-coordinate, you just plug it back into the function. So you'll have -2 squared is 4 minus 4 times -2 is plus 8 and then plus 5. So it'll be 9. So the vertex is at -2, 9. Thirdly, the domain and range again. So the domain's always just -infinity to infinity. It's everything. Then the range, if it's a sad face, it'll go from -infinity to the y-coordinate of the vertex. Okay. Fourthly, then, as usual, get your x-intercept and y-intercept. So for the x-intercept, I'm gonna set it equal to 0 and then multiply everything by -1, so it's easier to work with. Okay. So originally, set equal to 0, -x squared minus 4x plus 5. Multiplying by -1, I'll have 0 equals x squared plus 4x minus 5. So it just changes all the signs. Then I can factor that. You know, you hope you don't have to use a quadratic. Sometimes you do. Sometimes you have to use a quadratic formula, but here you can get away with not using it, so let's not. So I'll have x plus 5, x minus 1, and our 2 intercepts, -5, and then x equals 1 when you set it equal to 0 and solve. The y-intercept's always easy for these. You let x equal 0, you're just going to end up with y equals 5. Okay, so let's get a graph going. I need to go up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The y-intercept's at 5. 1, 2, 3, 4, 5. The vertex is -1, 2, 9. And then the x-intercept's -1, 2, 3, 4, 5, and then 1. Okay, as usual, connect the dots, and you should have your picture. Oops, I butchered that. It should be, you know, smooth. That looks kind of junky, but all right. So there's that. The next set of problems then are solving quadratic forms. So these look like kind of quadratic equations, and in general you can just factor them. So like number 7 is x plus square root of x minus 2 equals 0. So it has you kind of imagine it's the form x squared plus x minus 2 equals 0. So in that case it would have been x plus 2, x minus 1 equals 0. So over here it's kind of the same deal, except instead of x you'll have square root of x, and then square root of x, and then plus 2 minus 1. Set each part equal to 0, so square root of x plus 2 is 0. Square root of x is -2. This is square root equation. Square both sides, you get x is 4. Then you're going to have to check your solution. For the other guy, square root of x minus 1 is 0. So square root of x equals 1, so x is 1. Then you could go back to the original equation and do checks. So check x equals 4. Okay, I think in the lecture notes I kind of just went back to that equation. You could do that too, but I'll go back to the original because that's what the book does. So 4 plus square root 4 is 2 minus 2 equals 0. Left hand side, right hand side. 6 minus 2 is 0. 4 is, no, that's false, so that one doesn't work. Let's check the other guy. So x equals 1. So I have 1 plus square root of 1 is 1, minus 2 is on the other side, you have 0. So I have 2 minus 2 on the left, 0 on the right, 0 on the left, 0 on the right. That is true. So the only solution is 1, and we toss out the other guy. Okay. Let's look at one more of those. So this is number 19. We got x to the negative 2 minus x to the negative 1 minus 20 equals 0. Okay. So if normal, it would be like x squared minus x minus 20, and then our numbers will probably be minus 5 plus 4, right? I mean, you can almost just borrow that middle term and kind of put it over here. That will be these guys. Okay. I mean, the variable part. If there's a number in front of it, you can't do that. Okay. But you know, you're thinking this times this equals this. All right. So it's basically, I guess, the square root. You just take the square root of x to the negative 2. You know, x to the negative 2 raised to the 1/2 is x to the negative 1/2. You have to multiply the exponents, and that's what's going in where I have the arrows. Okay. Again, you have to take each part and set it equal to 0. This time you're going to get rational equations, so they'll be fractions. You know. Add 5 to the other side, you get x to the negative 1 equals 5. In other words, 1 over x equals 5. You can kind of cross multiply if you want. 5x equals 1, so x is 1/5. Okay. For the other guy, it'll be 1 over x plus 4 is 0, so 1 over x equals negative 4. And if you want to, you could literally just flip both sides, so it would be x equals negative 1/4. Okay, those will be your solutions. As far as checking solutions here, you don't necessarily have to. You could just make sure that it's not equal to 0. So the only issue would have been because our original equation is 1 over x squared minus 1 over x minus 20 equals 0. You just have to make sure that these denominators are not 0. In other words, you have to make sure x is not 0. So at the end of the day, neither answer was 0, so you're good to go there. Okay. Anyways, moving on then to the next chapter, 12.1. I'd be thinking of problems like 11 to 37. And first, we kind of just introduce exponential functions and their graphs. So I'd be expecting you to be able to graph these things. Let's look at 13, sure. So I have f of x equals 3 to the x minus 1. Okay, so they're starting to introduce you to this idea of translating graphs in the xy plane. But anyways, moving them around, right? Moving it left, moving it right, moving it up, moving it down. We'll ask you to do a table from negative 2 to 2. Then you have 3 to the negative 2 is 1 over 3 to the 2 power. 3 squared is 9. 1 is the same as 9 over 9, so this would be negative 8/9. Then 3 to the negative 1 is the same as 1 over 3 minus 3 over 3. That would be negative 2/3. Plug in 0, you get 3 to the 0 is 1, minus 1 is just 0. 3 to the 1 is just 3, minus 1 is 2. Finally, 3 squared is 9, minus 1 is 8. Okay, so let's go over here and graph the thing. 2, 3, 4, 5, 6, 7, 8. Kind of trying this. This goes over to negative 2. So at negative 2, it's negative 8/9. It's right before negative 1. Negative 2/3 then. At 0, it's 0. At 1, it's 2. At 2, it's 8. So these things should look like ramps, and they have horizontal asymptotes. The horizontal asymptote for this guy is at negative 1. So it kind of levels off there, right? It'll level off there, and then it shoots up. This is just the same as the graph of f of x equals 3 to the x, but shifted down one place. Okay, so there were other questions in this set, like number 29, where they would ask you to graph both of them and then explain the difference between the two, or explain how they're related, right? So in this case, you would do, I guess, 2 tables, and again, just go from negative 2 to positive 2. So you'd get 1/4, 1/2, 1, 2, and 4. And then for the other graph, -2, you'd get 1/4, but then plus 1. 1 is the same as 4/4, so this is 5/4. -1 will be 1/2 plus 2/2, which is, of course, 3/2. 0 will be 1 plus 1, which is 2. 1 will be 2 plus 1, which is 3. And then 2 will be 4 plus 1, which is 5. Then we want to graph them both and kind of see the relationship between the two of them. Right, so at -2 you get 1/4, -1 you get 1/2, 0 you get 1, 1 you get 2, and then 2 you get 4. So there is f of x, and again it has a horizontal asymptote at y equals 0, okay, the x-axis, so it levels off like that. Then the other guy, it's basically the same graph but shifted up 1. Okay, so its horizontal asymptote will be at 1. Okay, so you have -2 5/4 is a little bit above 1, and -1 3/2, which is 1.5, 0 2, 1 3, and you could definitely see it's just basically the same graph moved up, and then 2 5. Okay, so it'll level off at 1, and then it just does its ramp thing straight up. So this is G, this is F. And then you have to note that G is F shifted up one place. Okay. Okay. 12.2, we finally introduce you to the logarithm. So mainly in 12.2, I'm just asking you to evaluate logarithms. So I'll probably give you a whole bunch of these. Let me just write them out. I put 6 in the review. I don't know how many I'll put on the test though. And then 59. Okay, so first, what are they asking for? They're asking kind of 5 to what power equals 1/5. And you could write 1/5 as 5 to the -1 and then clearly see x is -1. So the answer here is -1. Second one, 7 to what power equals the square root of 7? The square root of 7 is the same as 7 to 1/2. So clearly x is just equal to 1/2. So the answer is 1/2. This last guy, 64 to what power equals 8? So 8 is really 64 to the 1/2, right? If you take the square root of 64, you get 8. So the answer is 1/2. ln of 1. So these are the natural logs. There's also the common log. The common log has base 10. The natural log has base e. So the question here is e to what power equals 1, right? And that's 0. The next one is asking e to what power is e to the 6. That's pretty clear. That's just 6. And then the last one, e to what power equals 1/e to the 6. You can rewrite it as e to the -6. So clearly x is equal to -6. Okay. All right, 12.3, we worked on expanding and condensing logs using the properties of logs. So there was 3 properties: product, quotient, and power laws. So we're looking at problems like 1 to 59. I just picked 2 out of the book, but there may be more on the test. Anyways, the first type was to expand. So they basically give you one log and they want you to make it into a sum or difference of logs. So get rid of all the exponents, the square roots, and quotients and products. So I'll use the quotient rule. This is log base 4 of square root of x, which is x to the 1/2, minus log base 4 of 64. For the first guy, you do the power rule, bring the 1/2 in front of the log. And then the second one you could reduce. It's asking 4 to what power is 64? Well, that'll be 4 cubed, right? So it'll just be minus 3. So make sure you're reducing everything. The other side of the coin is to condense. So looking at problems like 57, 3 ln x plus 5 ln y minus 6 ln z. So you want to rewrite this as one log without something in front of it, right? Without a coefficient. So first I'm going to use a power rule to bring the exponents in. Then I'm going to use the product rule on the first two logs. Then you could use the quotient rule. So you get the ln of x cubed y to the 5th divided by z to the 6th. And that's all inside that natural log. Okay. Okay. 12.4 was on exponential and logarithmic equations. And there was two forms of each. For 17, for the first type of problem, you're trying to get the same base on both sides, and then you just equate the exponents. Okay. So 4 is the same as 2 squared. 1 over root 2 is the same as 1 all over 2 to the 1/2. The rule for exponents is to multiply exponents when you have the parentheses like that. So you get e to the, or 2 to the 2x, and on the right you can rewrite that as 2 to the negative 1/2. So you get the same base on both sides, so you just equate the exponents. 2x equals negative 1/2. Then multiply both sides by 1/2 to isolate x. So you get x is negative 1/4. The other type was to isolate the exponential portion and take logs on both sides. Okay, so first I want to isolate this term, that factor. So I'll divide both sides by 1250, reduce just a little bit, make my life a little easier, get rid of the zeros. Then I'm going to take the log on both sides. And on the left here, the ln and the e kind of cancel each other out, and you just get 0.055x equals ln, and that all is inside the ln. 375 over 125, it's all inside the ln. Okay. Finally, divide. X is the ln of 375 over 125 divided by 0.055. I'll probably ask for 2 decimals on the test, so 19.97 if you put that into your calculator. Okay. So that was the exponential equations. After that we had log equations, and there's basically 2 types of those as well. The ones where you're using the definition to find the answer, and the other one where you're equating the insides of the logs. So you get a log on one side, log on the other, and just make the insides the same, equal to each other. Okay. Let's look at 61. So I have 6 plus 2 ln x equals 5. First, what I want to do is isolate the ln x portion. Just going to move the 6 over, divide by 2. And at this point you can exponentiate both sides, basically, is how some teachers will think of it, but it's really using the definition, because ln of x is log base e of x. You can rewrite this as e to the negative 1/2 equals x, and that it literally is your answer, e to the negative 1/2. You get an approximation if you need it. You got to check these guys. So I get 6 plus 2 ln of e to the negative 1/2 equals 5. So you're keeping the sides separate, left-hand side, right-hand side. Over here on the left, 6 plus 2 ln of e to the negative 1/2 is just negative 1/2. On the right you have 5 still. 6, then minus 1, on the left, 5 on the right, 5 on the left, 5 on the right. They're both the same. That's true. Therefore, it's a solution. Okay. 67 is the same type, but this time we have to use the properties of logs to simplify, and then we'll use the definition of the log to set up our equation. Okay. All right, so first I'm going to use the product rule, and I'll have x minus 5 times x plus 3 equals 2. Then you have, from the definition, 3 to the second power equals x minus 5 times x plus 3. Let's go ahead and FOIL that out, right? So I have x squared minus 5x plus 3x is minus 2x, and then minus 15. 3 squared, of course, is 9. Subtract 9 to both sides. Factor. Set each part equal to 0. And then check your solutions. So let's check x equals 6. So I got log base 3 of 6 minus 1 is 1, plus log base 3 of 6 plus 3 is 9, equals 2 on the right. So on the left, 3 to what power is 1? That's just 0. The second term, 3 to what power is 9? That's 2. 0 plus 2 is 2. Okay, both on the same sides are the same, so it's true. Check the other guy. X is negative 4. So I got log base 3 of negative 4 minus 5 is negative 9. As soon as you get a negative in a log or a 0 in a log, you're done. That can't happen. We can't allow negatives or zeros in logs. So you're going to toss out that answer and just leave the 6. Okay. Okay. Finally then, 12.5. So I'll probably give you an exponential decay type problem. Radioactive decay, some sort of radioactive decay problem. So thinking 21 to 31. 29, they give you the half-life of lead. The half-life of lead is 22 years. Then they're going to ask how long until it decays to 80% of its original amount. So the formula will probably be given in the story problem. A equals a sub 0 e to the kt. First, use the half-life to get the k value, the growth constant. So in 22 years, so you go a sub 0 e to the 22k, there'll be half the original amount left, so 1/2 a sub 0. Okay. Divide both sides by a sub 0. Get 1/2 equals e to the 22k. Take ln on both sides. On the right, the ln and the e's kind of cancel each other out. You get 22k. Finally, divide both sides by 22. Get the ln of 1/2 over 22. If you're going to get an approximation, go the 4 decimals. I'm just going to leave it as is. Okay, and then use that. So the second part of my question is how long until 80% of the original amount, until it decays to 80% of the original amount. So to set that up, you're going 0.8 time of means to multiply. This word of basically means multiply of the original amount. The original amount was a sub 0. Okay. So on this other side we have a sub 0 e to the k, which is now ln of 1/2 over 22t. And we're solving this for t. So first divide both sides by a sub 0. Take the ln on both sides. The ln and e on the right side will cancel with each other, just giving you ln of 1/2 over 22t. And then you're going to multiply by the reciprocal of ln of 1/2 over 22. Okay, so what is that? That's just 22 all over ln of 1/2 on both sides. So times 22 all over ln of 1/2. If you want, you could write it as ln of 0.8 over 1 to keep everything kind of straight. I'm going to flip-flop sides, so I'll have t equals 22 ln of 0.8 all over ln of 1/2. Put it in the calculator, probably get 1 or 2 decimal approximation, read the directions, 7.08 years for the lead to decay. Okay, all right, so kind of a lot of material on this test, but hopefully, given these types of questions, you'll go back and look at the question pools, make sure you can do those. Make sure you can do the problems around the problems I did here in my review, and hopefully you'll be okay. Okay. All right. As usual, thank you for watching, and I'll see you next time.